Yes, a very good evening to all of you. I hope I am visible and audible to everyone over here. Yes, a very good evening to all of you. I hope you people are doing well. Yes, good evening, Jyotika, Neha, Priyanka. Okay, last class, hopefully you people have followed it, right? That was anyhow introductory part. Okay, that's basically the kind of historical background which was there. Right, today we'll be moving into more of more of the important topics which are there, right? But definitely without history we cannot, proceed further. So that is the reason we have discussed that first. I hope everybody is able to listen to me properly. I hope there is no issue with the audio or visual wise. Absolutely fine. Okay, fine. Then we'll start off the session. So in the last class, I think we have started off with, we finished off the modern periodic table, right? And in that long form of modern periodic table, we have seen how the things are there, how many groups are there, how many periods are there. So we have already seen that, right? And I think we have written some of the important points also, how many elements are gases, how many of them are liquid and all those stuff. I hope that is clear to you, okay? Now today we'll proceed further in that series itself. So today we are going to learn about classification of elements, right? So classification of the element means basically we are going to divide, or else we already know that in modern periodic table, the entire elements, we have divided them majorly into 4 different blocks. That is S, P, D and F, right? Now the thing is, how do we decide, how do we divide them, on what basis? So some of you might say that, ma'am, it's basically on the electronic configuration. That's correct. Because the thing is, once we write the electronic configuration, then only we come to know that where the last electron is entering. That means in which orbital the last electron is entering. And accordingly, we'll be telling whether it is S block, P block, D block or F blocks. So in general, if I can say that if the last electron and that lasts from each other, whether it is S block, P block, D block or F block. So I say that if, like, it all depends upon, or else the elements can be classified on the basis of in which orbital your last electron or differentiating electron is entering. That's what is the classification basis. So let us write that, okay? So here I am going to write down elements are classified into 4 blocks, that is S, P, D and F, depending upon where the last, or depending upon, we'll better write down in a better way here, depending upon in which orbital the last or differentiating electron is entering, right? So based on that, we'll be saying whether it is S, P, D or F, okay? Now, so the first one is we are writing S block elements. Now when it comes to S block elements, let us take the simplest example, which is of lithium. When I write down its configuration, I write it as 1s2 2s1, right? Now the thing is, in case of lithium, where do you see the last electron is entering? It is entering into the S orbital, right? So I say that basically because of this, as the electron is entering, last electron is entering into the S orbital, I say that basically it is S block element, okay? So here I am going to write down the definition of this. So the elements in which last electron enters into s orbital of the valence shell. What is this valence shell? Valence shell is basically the outermost shell. That is what is valence shell. Okay. Now, the thing is, you might have observed, that's what is the definition as such. Now, what about general electronic configuration? EC is basically the electronic configuration. Okay. Now, when it comes to general electronic configuration, we can write in terms of inert gas as such. So, inert gas, right? And then NS 1 to 2, right? So, if at all somebody is asking me to write down about lithium, so lithium is 3, I'll be writing 1s2, 2s1. So, even I can write like this, helium is 1s2 and 2s1. That means you have to identify a particular inert gas which came before lithium, and that is basically your helium. Okay. Now, hopefully this is clear to all of you. This is general in electronic configuration, and the thing is, from this also a question, very simple question can be actually made, right? They can ask you like which is the identify the general electronic configuration for S, P, D or F, right? So they easily question can be made, and which could be scoring. Now in the periodic table, which are the two groups, or else which are the groups which come under this S block elements, right? Which are those groups? Can anybody answer? Yes, correct. Majority of you are able to say that is basically group 1 and group 2. So group 1 and 2 elements are S block elements. Now the thing is, these two block elements, that means S block elements, they are known as, all of them, they are going to be metals, because we already call them alkali metals, alkaline earth metals, right? So do remember, they all are metals, right? So hopefully this is very clear to all of you. So please make a note of it, and then we'll proceed further. Yes, I hope people have written this. Okay, so let us move on to the next one, which is basically P block elements. Now when it comes to P block elements, the way we have defined for S block element, that means the elements in which the last electron is entering into S orbital, this time it will be P orbital of the valence shell. So suppose if I take the example of aluminium, which is 13, so I can write 1s2, 2s2, 2p6, 3s2, 3p1. So where the electron has entered into the P orbital, right, of the valence shell. Okay. So we are going to write down the elements in which last electron enters into P orbital of the valence shell. That is only known as P block elements. Now we'll write down the general electronic configuration for this, which is inert gas. Then we are going to write NS2 is completely filled, then NP 1 to 6. That means P subshell is getting progressively filled. Okay. So P1 to P6, that's the meaning of it. Now here, what are those, like how many groups constitute basically the P block element? How many of that from the periodic table? Yes, good. Many of you are able to answer. Yeah, good. Good, Neha, Priyanka. That's going to be group 13 to 18. That will constitute the P block elements, right? So group 13 to 18 constitute the p block elements, right? Now here we have already seen that metalloids we have seen now, that silicon, germanium, antimony, tellurium, polonium, all those. So metalloids are there, right? We have seen like this, something like this we have made yesterday, right? So this was like silicon, germanium, antimony, tellurium, like that. So the thing is, above that, you are having basically non-metals, and below that in the p block you are having metals, right? Aluminium is a metal, right? Gallium is a metal, okay? So we can say that in p block elements, basically you are having all the three categories. You are having metals, you are having non-metals, and you are also having metalloids, right? So we can say they contain, or else they include, that will be better word, they include metals, non-metals and metalloids, right? That's what is p block element. So please make a note of it and then we'll proceed further. And I hope you people are able to follow. EC is electronic configuration. Okay, hopefully people have written. So we'll move on to the next one. So the next class of element is basically D block elements. Now before writing the definition of it, let us take a very simple example, which is basically scandium. So when I write its configuration, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Now you are able to see where the last electron has entered. It has entered into d orbital, right? Now the thing is, what is the value of n here? That means the shell, highest, what is the valence shell here? Basically valence shell is 4 here, and n, which is a principal quantum number, it represents that, okay? Now the thing is, your electron has entered into n minus 1d, that means 4 minus 1d, which is 3d. Getting it? So we'll say that the elements in which last electron is entering into n minus 1d orbital, that is d block element. Now there is one more name for this n minus 1. N is outermost shell, is ultimate shell or valence shell, we say, right? If it is n minus 1d, n minus 1, what is the name of that? Yes, some of you are able to write correct. That is penultimate shell. Okay, good. So we are going to write here the elements in which the last electron enters into n minus 1d orbital or d orbital of penultimate shell. D orbital of penultimate shell. That is known as D block element. And now when I say penultimate, it is n minus 1. Okay. Now we are going to write down its general electronic configuration. General electronic configuration is, again, we are writing in terms of inert gas. So inert gas, n minus 1d, 1 to 10, ns 0 to 2. This is the general configuration. Okay. Now, what are the groups which come under D block? You are already like in the periodic table, you know, group 1, group 2 gone for S block, then group 13 to 18 gone for P block. Only ones which are remaining is 3 to 12, right? So, group 3 to 12 constitute D block elements, right? And in fact, you must be very clear that they all are metals, right? So in the periodic table, you should be very sure of that when you consider S block elements, when you consider D block elements, and when you consider F block elements, they all are metals. There should not be any confusion about that. Okay. So please write this. because further we are going to write about the series here. So I'm writing the D block elements as such. Yesterday or else day before yesterday in I think a particular class, I have told you about 3D series, 4D series, 5D series and 6D series, right? So those are the transition series into which your D block can be further divided. So that's what we are going to just write it down. We are not going to write down the entire series, but we should know from which element it is starting and which it is ending. Okay. The D block elements are further classified into 4 transition series, which are as follows. Right? So first finish writing this, then we'll proceed further. Yes, I hope we are done writing it. So let us proceed further. First one in this, we are still in the D block element. We are just writing down all those important points which are required. Okay. So first transition series, which is also known as 3D series. Now first transition series, basically you have seen that it starts from scandium, it goes up to zinc. The atomic number here is 21 and it is 30. In each of these series you are getting basically 10 elements. It consists of 10 elements. Now why do we call it as 3D series? Because the thing is, when you start from scandium, you move up to zinc, 3D subshell is getting, progressively filled by the electrons, like 1 electron, 2 electron, up to 10. That's the reason it is known as 3D series. Okay, so we'll write down here, filling of electrons takes place progressively in 3D subshell, right? That's what is first transition series. Now next one is second transition series. Second transition series, which is also known as 4D series. Now the thing is, it starts from yttrium, it goes up to cadmium. Now the thing is, you add 18 to this scandium and 18 to this, because in between there are total 18 elements, because 2 S block elements, 6 P block and 10 D block elements, right? So that is the reason we are adding 18 over here. So basically it will be 39 to 48. And here also there are 10 elements in this series. It is known as 4D series. Reason being, yes, very good. Many of you could even say that why is it? Because the electrons are progressively getting filled up in 4D subshell. Okay. So we can say the electrons are progressively being filled up in 4D subshell. Okay. I hope people are able to write. Okay. Next one is third transition series. So in third transition series, basically we call this as 5D series, right? And it basically starts off with lanthanum, which is 57. Again, what we are doing is we are adding 18 only to this, because after lanthanum only you are having basically your lanthanoids basically which start off. So after lanthanum, you will be having cerium to lutetium, which is basically 58 to 71, and I'm writing this as F block element. This I am writing only so that you understand, you can relate the things, okay? So after lanthanum, there are 14 elements which are F block element, and after that again it is hafnium to basically mercury. Hafnium is 72, this is mercury is 80. So basically you just have to focus on this when we are talking about 5D series elements, and these are basically 10 elements which belong to this 5D series. Now here again I can write that filling of electron takes place in 5D subshell. Filling of electrons takes place in 5D subshell. Now the last one in this category is fourth transition series. Fourth transition series, which is known as 6D series. So basically it starts with actinium. Now you already know that there are 14 additional elements which have come. So till now we were adding 18, now you add 32. So basically you will be getting this as 89, and after that we know that it is thorium to lawrencium which is there, which is 90 to 103. They are also F block elements, right? And after that what is there? Basically you are having roentgenium to copernicium. So this is 104 to 112. Basically this is the element, these are the 10 elements which constitute this 6D series. So we can say that filling of electrons takes place in 6D subshell, right? So please make a note of it, all of you. Yes, that is actinium, and then I have written roentgenium, Cn is copernicium, right? So you'll be having zinc, cadmium, mercury, and copernicium in a particular group, right? So all this, whatever we have written, scandium to zinc, yttrium to cadmium, then lanthanum to you are having mercury, and then you are having actinium to copernicium. So basically all of them, they are in one group, they are in same group. This is group 3, this is group 12, right? So you must know that, okay? Yes, I'll show you the second point in case not written, first and second also. Okay, let us move further. So we are done with this D block element. Now, next one is F block elements. Now, in case of F block elements, when we look at their configurations, basically it is seen that the last electron is entering into N-2F, right? And that N-2 shell is basically known as anti-penultimate shell, okay? So we are going to write down the elements in which last electron enters into N-2 F orbital or F orbital of anti-penultimate shell. Anti-penultimate shell, right? And when I say anti-penultimate, I mean it is N-2. Okay. Now let us see what is the general electronic configuration here. It is inert gas N-2 F1 to 14, N minus 1, D0 to 1 and NS2. This is what is general configuration of it. And here they all are metals, F block elements can be classified into two. One is lanthanoids, which follow lanthanum, and others are actinoids, which follow actinium, right? Now the thing is, F block elements, they always belong to group 3, always, right? This belongs to period 6. This is to period 7, right? As such, we'll be also seeing like how to predict the group period block. But just like that, we have mentioned here so that as many number of times you'll be reading that or else, going through a particular thing that will get registered in your mind. So please make a note of it, then we'll proceed further. Okay, I hope people have written. Now let us write down further. The F block elements. Now the thing is, for D block element, we use the term that they are transition series. They were divided into 4 transition series. Now here what we are saying is that the F block elements, they are further divided into 2 inner transition series, right? So we are already calling D block element as transition series. Now within that there is a series, so we can also say that they are inner transition series. Okay, so we can say the F block elements are further classified into 2 inner transition series, 2 inner transition series, which are as follows. Okay. First one, that is the first inner transition series. And first inner transition series is basically called as 4F series. Now, why is it called as 4F series? Why is it called as 4F series? Yes, because the reason is the way we have declared 3D, 4D, similar way here also, because the electrons or else the 4F subshell is getting progressively filled by the electrons. Okay. So here basically it constitutes of cerium to lutetium. This is 58 to 71. They are known as lanthanoids. And we can also write here the filling of electrons takes place in 4F subshell. Okay, that's what is first inner transition series. Now next one is second inner transition series. Okay, and here you are having thorium to lawrencium, which is 90 to 103. They're also known as actinoids, and the way we are calling that as 4F series, here also we can call them as 5F series. So why I am calling them as 5F series? Because here the electrons are getting progressively filled up in 5F subshell. So we can write down the filling of electrons takes place in 5F subshell. That's the reason we are calling them as second inner transition series. Yes, all of you please make a note of it. Yes, written. Okay, we'll give you a little bit more time. Okay. Now, with this, we kind of finish off the all the classification here: S block, P block, D block, and F block elements. Now, there are certain terminologies which we need to know, and they are very common, and we are just going to write about them. Okay. So let us write down important terminologies. So in that, the first one is normal or representative elements. What are those elements? Basically, these are the elements whose outermost shell is only incomplete. Okay. So those are normal elements. And what are those? Basically, all the S and P block elements, if you see, their inner shell is going to be filled up, only outermost shell is incomplete. Okay. So here we are going to write down the elements in which the outermost shell is incomplete are known as normal elements. Normal elements. Now here basically I'll be calling S block and P block elements except group 18 elements are representative elements. Okay. Reason being, in case of group 18, all of them, they are having their outermost shell complete. They don't have outermost shell incomplete. Okay. So basically you must remember that. So please write this, then we'll proceed towards the next one. So normal or representative elements we have known. Second one is transition elements. Basically, we are using this term for D block elements, and that too those D block elements. Earlier, it was used like in general for all the D block elements, because there is a transition which is happening from very highly reactive S block element towards kind of non-metals which we are going through, right? Because in the entire periodic table, where is the location? S block, then D block, and then P block. So people used to think that there is a kind of transition in the property from highly reactive things to less reactive, right? So here transition elements. Okay. So transition elements, later on the definition was modified, that basically transition elements means only those d block elements in which there is like partially filled d orbital either in their ground state or in any of the stable oxidation state. Okay. So we are going to write down that. Hopefully people have written this normal or representative one. So I can write this, the D block elements in which partially filled d orbital is present either in ground state or in any stable oxidation state. In any stable oxidation state of the element. Okay. So please write down the definition. Hopefully you people have written about normal or representative also. Write down the definition, then we'll look into this. Yes, written. Okay. Now let us see example. Suppose if I take the example of nickel. Nickel is 28. It is a D block element. Now when I write down its configuration, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Right? Now the thing is, in its ground state, then also you are having at least like partially filled d orbital. It is not 3d10. The stable oxidation state is Ni plus 2. So in that, again we can remove the electron from the outermost shell, which is this one, right? So what I'll be getting is 1s2, 2s2, 2p6, 3s2, 3p6, and we are writing 3d8. So still there is partially filled d orbital, right? So because of that, we can say that the nickel is transition element, right? It's not necessary in both the cases it should follow, at least one of them. Either it should be in the ground state or else it should be in any stable oxidation state. Okay. Now let us take another example here. Suppose we talk about zinc, which is 30. So I'm going to write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Now the thing is, in its ground state, then also it is completely filled. Okay. Now, when I write Zn plus 2, which is the stable oxidation state in which your zinc can exist. So what you can write 1s2, 2s2, 2p6, 3s2, 3p6, and we can write 3d10 because we have to remove the electron from here outermost shell. And outermost shell is decided by the value of principal quantum number. So here it is 4. Okay, don't think that 3d is written outside, so it is the outermost shell. That is a different thing, that 3D is being filled up afterwards. And it is coming from that N plus L rule. Getting it? So here also, are you able to see that there it is fully filled? So basically, I'll say that zinc is not a transition element. Right? So basically, we'll say that whoever is coming below zinc, they are also following the same thing. That means zinc, cadmium, mercury, copernicium, right? So we will be able to say zinc, cadmium, mercury, copernicium. They all are group 12 elements, and basically they are not transition element. They are not transition element, right? So please write this. Finished writing? Okay, it can take a little bit more time, not an issue. Okay, so I'm going to write down one statement. All D block elements are transition element. And another one is all transition elements are D block elements. Which statement is correct? First one, is it correct? All the D block elements are transition element? No, it's not correct. Okay. So basically it is false. We have just seen, no? Zinc, cadmium, mercury, copernicium, they all are basically D block element, but they are not transition elements. All transition elements are D block elements. That's correct. So it is true. Right? So this could be asked, which of the following statement is correct? And one of the statement could be this, along with any other statement. Okay. Now let us go for typical elements. Now when I talk about typical elements, I'm saying that suppose there are few people from different countries. Suppose you went outside, and suppose you went to any other kind of any other part of the world except India, right? Maybe US itself. And how do you recognize anyone there? You maybe because of their kind of a typical kind of characteristic which is there. We Indians, we are more religious, right? Or else we are more kind of humble, or else whatever are the characteristic which you can think of, right? So you can easily make out who is Indian, who is Chinese, right? And who is from any other part of the world, right? So the word typical I want to say, right? Typical in the sense which is basically representing the kind of like a particular kind of behavior which can be generalized for anyone, right? Or else which is showing the behavior of a particular set or particular kind. Now, when I talk about typical elements here, so basically all the third period elements, they are going to be called as typical elements. Suppose if at all I talk about lithium, sodium, potassium, then beryllium, magnesium, calcium, boron, aluminium, gallium, carbon, silicon, germanium. I'm not writing the entire thing. Now the thing is, second period elements, you'll always study that basically they show the anomalous behavior, right? Why they are showing anomalous behavior? First of all, they're very small in size. And after that, what is there? They don't have the vacant d orbital. They belong to the second period. So they just have 2s and 2p which is there. There is no 2d which is there. Okay. Now when it comes to this third period, fourth period, right? So they have that vacant 3D and all those stuff, right? Now the thing is, they represent actual behavior of, or is they kind of class monitor of their group. They are representing the behavior or the properties of their group. Getting it? So that's what is typical elements. So we can write down third period elements which are sodium, magnesium, aluminium, silicon, sulfur, chlorine, okay, are known as typical elements as they represent the characteristic of their group, of their entire group. Okay, so you can read them like monitors of the class. Now the last one in this is trans-uranic elements. So what does this stands for? Trans-uranic element means basically the elements which follow after uranium, right? That means uranium atomic number is 92. So anything after that is basically trans-uranic elements, okay? So the elements placed after uranium, that is here Z is greater than 92, okay? Because atomic number of this is 92, are known as trans-uranic elements. That's the meaning of it. So please make a note of it. Both the things, typical as well as trans-uranic, then we'll proceed further. Yes, written everybody? And you can include phosphorus also there. We missed on one of the element. Group 14, 15, 16, 17. Okay. Yes, I hope it is clear now. Now let us move towards the important segment from where you can expect the questions, which is prediction of group, block, period, all those things. So prediction of period, group number and block. So basically we'll be seeing two of the cases, right? Major two cases. First one is if the atomic number is given, right? And if the atomic number is given, we need to remember which kind of like, what is the series which is there, right? Which can easily help you out. So in this case one, which is if the atomic number lies in the range 58 to 71 and 90 to 103. Okay. You might have easily guessed 58 to 71 means I am talking about lanthanoids, and 90 to 103 that means I am talking about actinoids. Okay. So we write here if the atomic number, this is I've written atomic number, okay, AT dot, okay. So atomic number is between, this is between, okay, is between 58 to 71. So first of all, I declare that as F block element, right? That means I got the block. So I can write the block is F. If it is F block, then the group number is fixed. It is going to be 3, or else in this form third B. And what about period? If you remember, we have written for lanthanoids, they belong to 6th period. Okay. Now, I am writing further for the another one. If the atomic number is between 90 to 103. So again, block is fixed. Block is going to be F. What about group number? For all the F block element, group number is 3 or third B. And they are basically actinoids. So the period is going to be 7. Right? Here I am writing 6. Okay. So please make a note of it. Then we'll proceed further. I think I little bit increase the font size so that it is readable for you people. Yes, I hope it is written. Now let us move on to this case 2 in this only, right? So if the atomic number is present in the range, of 104 to 118, okay? So let us see how do we proceed for this. if atomic number is present between 104 to 112. So first of all, what we need to see, definitely when we are talking about this period is going to be last one. We are talking about like up to 118, no, 104 to 118. So they are in the last period. Okay. Now, what about group number? Group number is equal to the last two digit of the atomic number. Okay. And what about the block? So 104 to 112, basically it is D block element. Okay. So this is going to be a D block element. Now suppose for example, if I take this, if I give you this example, 110, right? There is certain element whose atomic number is 110. Now the thing is, period for this is fixed, which is 7. Now block for this, it is fixed, it is D block. And the group number, if somebody asks you, it is going to be 10, which is the last two digit of it. Simple. Okay. Now, if the atomic number is present between 113 to 118. So again here, period is fixed, which is 7th. Block this time changes to P block because 113, which is nihonium, it belongs to group 13. And then you proceed towards 118, which is group 18 element. Okay. So this is block is already done. Then we are looking for group number. So group number is also decided by the same way. Last two digit of the atomic number. Last two digit of the atomic number. So please all of you make a note, right? And then we'll proceed further. So suppose if at all I am asking about 118 itself. So 118 means period is fixed 7, block will be P, and which is the group number? It is going to be 18th. That means noble gases. So suppose if I write one example, which is 117. So in that case, period is 7, block it is fixed, it is P block, and group number is going to be 17. That means it is last two digit of it. Okay. So please make sure that you are writing, and then we'll proceed further. AT.NO is basically atomic number. Okay, I have written that in short form. 112 is copernicium. 118 is oganesson. Hopefully you people should remember that, all of them. Okay. Now let us proceed further. Now we are going to look for the second one from electronic configuration. Now when I talk about from electronic configuration, that means either the examiner could give you the electronic configuration or else the atomic number could be given to you. On the basis of that, you have to predict the group number, block period and all those things, right? So for this, we'll be writing period corresponds to the principal quantum number of the valence shell, and block corresponds to the subshell in which last electron is entering. Then for group, the thing is we must predict block prior to deciding the group. Okay. So for groups, if at all we have already determined that it is S block. So for S block, group number is given by number of electrons in valence shell, that means the outermost shell, or else we say that the number of electrons in NS. N stands for the principal quantum number of the valence shell. Okay. Now, if at all we are having P block, so for P block, we can predict the group number as 10 plus number of electrons in valence shell. Or else I can write 10 plus Ns plus Np electrons. That means 10 plus number of electrons in Ns plus number of electron in Np, or else we can also write 12 plus number of electrons in Np. See, the thing is I have not explained you anything so far. We are just writing down the formulas and I'll tell you each and everything. Don't worry about it. Okay. Now, next here is third one, which is D block. For D block, group number is given by number of electrons in N minus 1D plus number of electrons in Ns. That's how we decide for D block. For F block, do I need to do anything? It is fixed that it is group 3. So F block always means that the group number is 3. So please make a note of it, then we'll proceed further. This I'll show the above one also, that is block and period, in case somebody has like they've not written it. So don't worry about that. First finish off this and then we'll understand the things. Yes, written. So I'll scroll up this one also so that you people are having idea about this. And this is an important aspect from where you can easily expect question. As such, it is simple also. Anything could be learned if at all you pay attention to it. That's the only kind of requirement. Okay. Now here, before we proceed towards the example, in this only you write down one more thing which is important is you must remember the atomic number of all the inert gases, because in terms of them also when you write down the electronic configuration, your work is kind of reduced and it is much easier for you to identify, right? So helium, neon, argon, krypton, xenon, radon, and purposely not writing organization because it is not required, right? That is the last, actually the last period. So you are having atomic number as 2, 10, 18, 36, 54 and 86. This marks the ending of first period, right? This marks the ending of second period. This marks the ending of third period. This marks the ending of fourth period. This marks the ending of fifth period, and this marks the ending of sixth period, right? Hydrogen, helium. So helium is telling you that okay, first period is over. Then neon is telling you that second period is over. Then the next, whichever is the element, then actually new shell or else new energy level is going to get filled up. Okay. So this, remembering this is important. Okay, let us see few examples here. So if at all, in those examples, let us say I am giving you, suppose magnesium. Magnesium is 12, right? Now the thing is, when I write down its configuration, it is 1s2, 2s2, 2p6, and then 3s2, right? Now the thing is, which is like, what is the period here, or else what is the principal quantum number of the valence shell? Valence shell here will be the outermost shell. Outermost shell is 1, 2, 3 from the nucleus when you see, right? So the outermost shell is 3. So basically your period you got, that is basically 3, right? Now next is, what do we want? Basically we want to know about the group number, right? Or else you identify first the block, because to identify the group number, we first know what is the block, right? Now where the last electron is entering, it is entering into the S. So basically block you have identified, that block is S, right? Then after determining the S block, so what we see that basically the group number is the number of electrons in the valence shell. This is the valence shell. How many electrons are there? 2. Or else we say the number of electrons in NS. So it is basically 2. So you already know magnesium belongs to group 2, right? Now let us see how we can predict from here. That means in terms of inert gases also, either way, right? Now the thing is, magnesium, you identify the inert gas just before magnesium. So which would have come? Definitely neon. So we are going to write down neon. So 10 electrons are gone. Now neon marks the ending of second period. So now which period is going to fill up now? Third one, right? So third one, in that every time the periodic table begins with what? S, and then it is like P here, and in between it is D. Now you already know for first, second and third, there is nothing like D block element which comes in. So what we are going to write here is, basically you are going to write 3s2. Already 12 electrons done. So now you already got what is the period. Period is 3. Block is S. And how many electrons here? 2. So group number is 2. So please make a note of it. Then we'll proceed further. Second one. Suppose I am taking arsenic, which is 33. Right? Now the thing is, I can write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p. How many are there? 10, 20, 30 and 33. Right? You are able to see I have written the electronic configuration. Now, what is the period number here? Period is, outermost shell is 4. So period is 4. What about block? where the last electron has entered. It has entered into P. So it is P block. What about group number? Once it is P block, we can find out 10 plus the number of valence shell electrons. So valence shell is this one. You're able to see? N equal to 4. That is the valence shell. So how many electrons in the valence shell? 2 plus 3. So it becomes 15. Right? So it is 15th group 1. Or else I could have written like 10 plus number of valence electrons directly. Or else I could have written like this. 12 plus number of electrons in P. How many are there? 3. So it is 15. Right? So either way you can go for. Hopefully you people have understood what I have written here. First you copy down that, and then in terms of inert gases also we'll do that. Yes, hopefully everybody has written for magnesium. Now in this case for arsenic, arsenic is 33. Now you recall helium, neon, argon, krypton, right? Now the thing is it is 2, 10, 18 and 36. So which is the inert gas before arsenic, which is 33? Before that it is 18. Okay. Now the thing is we are going to write down for arsenic. We are going to write down. First we are going to write down argon. So argon marks the ending of third period. So that means the next electron is going to enter in fourth, right? So this is 18 electrons gone. Then you are having 4s2, 3d10, 4p3. And always remember it is like ns, n minus 2f, n minus 1d and np. You remember like that. ns, 4s. We don't have anything like 2f. That is the reason we have not written. Then n minus 1d, that is 3d, and np, 4p. Are you getting it? Remembering this sequence will help you out. Okay. ns, that is coming from that n plus l rule. Okay. And we don't have to blindly write f. We must know that 2f does not exist. It is 4f and 5f only which exist. So if somewhere I am having n equal to 6, so I'll be able to write 6s, 4f, 5d, 6p. That's the meaning of it. Okay. Now the thing is, from here what you are able to see, the last electron entered into p, and basically what is the principal quantum number of the valence shell? It is 4. So basically you got period as 4, block as p, and group number will be equal to what? 10 plus number of valence electrons, which is 5, which is 15. So valence electron means this. N equal to 4 is the valence shell. So all the electrons which are there in the fourth shell, they will be part of the number of electrons in valence shell. I have not written the other way because I have already written it above. It is the same, right? So hopefully you have understood this. Note this down, then we'll proceed further. Yes, are we done? Okay, now let us proceed for the another problem. Let us say I am giving you Mn which is 25, right? So when I write down its configuration, it is 1s2, 2s2, 2p6, 4s2, 3d5. That's how we write down the configuration, right? Now the thing is, if at all somebody is asking me about the period, so what is the value of the principal quantum number of the valence shell here? Valence shell is highest value of n, right? Don't count 3d as the outermost shell, right? It is only decided by the n value 1, 2, 3, 4 like that. Okay, it's based on the n plus L rule that basically 3d is getting filled up afterwards after the 4s. So period is going to be 4, right? That you got it clearly? Now, what is the block? Where the last electron was entering, it entered into 3d subshell, right? So we are going to call this as D block, right? Now, once you have identified it as D block, then you identify the group number. For group number, what we have to do, number of electrons in n minus 1d plus number of electrons in ns. That's what we have to find out. Okay. Now the thing is, we have already identified what is the value of n. N is 4. So basically we need to see how many electrons in 4s and how many electrons in n minus 1d, which makes it 3d. Getting it? So how many electrons in 3d? There are 5. And how many electrons in 4s, which is ns? It is 2. So basically it belongs to 7th group. And you can easily check that out. And so you've got the entire periodic table to check. Okay, you can easily do that. Now, if at all I want to write down in terms of this helium, neon, argon, krypton, right? So it is 2, 10, 18 and you are having basically 36. So please find it out with this particular one also, whether you are getting the same answer or not. So we are going to match with the argon, because argon is before that. So we are going to write down for Mn in terms of argon. So argon 18 is done. Argon marks the end of third period. First period, second period, third period. So the electron has to enter into 4s. 4s2. So already 20 electrons done. How many are remaining? 5 more. So 3d5. Right? So from here it becomes easier. Period is going to be 4. Block is going to be D block. And group number is going to be 2 plus 5, which is 7. Got it? Now the thing is, for F block elements, you need not worry. You just identify the range there. Okay? First you make a note of it and then we'll see few more questions here. And once you have written, please just write down thumbs up or something like that so that I can come to know. Okay. Able to follow? Good. So I'll give you few more. We'll practice in the class itself. So I'll just tell you few more like this. I'll just summarize it. Now the thing is, you must remember that if at all, you need not worry about F block elements, okay? You just identify it. I have given you 3 ranges, okay? One is 58 to 71, which is your lanthanoids, okay? So even if the configuration is given and somewhere, F is getting filled up, you can just count the electrons there, total electrons, and you see in which particular range it is coming. Whether it is coming under 58 to 71, directly declare it to be F block element, period is 6th and group is 3rd, right? Or else it is coming under that 90 to 103 range, okay? So even if the electronic configuration is given, you simply have to add it. Okay, or else if the atomic number is directly given, you can easily see whether it falls between 90 to 103. If it falls between that, then simply declare it to be F block element. Block is confirmed. If it is F block, then it is going to be group 3rd, right? And the period is going to be 7 for actinoids. Okay. Now, one more range which I have asked you to remember is from 104 to 1118, right? So, for 104 to 1118, you again split it into two. That is 104 to 112. So, 104 to 112, basically they all belong to last period, which is 7th period. Group number is given by the last two digit of that atomic number. And what about your period? Period will be given by, already we have seen that is 7th period, and block you will decide 104 to 112, it is P block. And if it is 113 to 118, it is, 104 to 112 is D block, my mistake, sorry for that. And 113 to 118, it is going to be P block, right? That's the only thing. And apart from that, if at all like smaller atomic numbers are there, or else like you can easily write down in terms of all these inert gases, you will end up with your answer correctly, okay? So let us do few questions here. Predict the period, block and group number for the following atomic numbers. So I am writing, suppose 23, 28, 38, 48, 58, 63, 68, 110. Okay, do few of them here. Please predict them. See, for few of them, you need not write anything. 58, 63, right? 68. So I've already reduced the work. 58. For 58, what I'll be writing? This belongs to which range? 58 to 71, right? So let us say I'm doing that. So for 58, it is going to be, block is going to be F block, period is going to be 6, and the thing is group number is going to be 3. This is same for your 63 as well as 68. For all of them it is the same thing now, because all of them they are coming under this range. Suppose if I give you one more, let us say 94, right? So again, can you guess, for 94 also you don't have to do anything. For 94, it is coming under which range? 90 to 103. It is coming under that range, right? So you got that this block is F, group number is 3, and period is going to be 7 because it is actinoids. Right? Now suppose if I want to do for 23 now. So 23 you can easily write helium, neon, argon, krypton. So you can write 2, 10, 18 and 36. So basically you can write down in terms of argon. So argon marks the end of which period? 3rd period. So next it is 4s2 and you are going to write down 3d3. Are you able to see? 18 plus 2. Okay. I need not write down the entire configuration because I can easily write down the configuration in terms of inert gases. Now basically you tell me what is the period here? Period is going to be 4. Block is going to be D block. Period is 4 because of the principal quantum number of the valence shell. Block is going to be D. And what about group number? Group number is going to be N minus 1 D electron and NS electron. So you are having 2 plus 3, which is 5. Yes, everybody got this answer? Then for 28. For 28 again, Which inert gas is closest to that? It is argon again. So you're going to write down argon. Argon is 18 and it marks the end of third period, right? So after that it is 4s2, 3d8. You are able to see? Right? Total, you have to keep a track of the electrons, right? So what is the period here? Period is 4. Block is D, and because the last electron entered into D, and the group number is 8 plus 2, which is 10. Got it? Hopefully all of you are able to follow. Now only ones remaining are 38, 48, hai na? So if at all I have to write down for 38, now you identify which inert gas is closest to that. This time I am going to write down in terms of krypton, right? So basically I will be writing krypton. Krypton is 36 and krypton marks the end of fourth period, right? Now the thing is, we are going to write down this as 5s2. Then the electron is complete? No, because every time filling of new energy level and you are starting from S block, okay? So here, what is the period here? It is simple now, it is 5. Block you are able to see, it is S. And what about group number? How many electrons in NS? 2. So group number is 2. Then next one, let us say we are going for 48. For 48, which inert gas I should take? You are having helium, neon, argon, krypton and xenon, right? So this is 36, it is 54. So again I should take 36 only, that is krypton, 36, right? Now the thing is, again I have to write down 5s2 and then I am going to write down 4d10. Then only it is 38 plus 10, which is 48. Now what is the period here? Period is fourth period. Block is D block. And the group number is again N minus 1D, which is 10, and NS electron. So 10 plus 2, which is 12. So group number is 12. Then I think one more remaining in this list which I have given you. In fact, you can practice for all of them which is there. And the entire periodic table is there with you. Then you are having 110. Now you remember 110? That means it belongs to which period? It is in that range, okay? So period is 7th. Block you remember? 104 to 112, D block. Group number, last 2 digit, which is 10 here. Getting it? Take one more here which I am giving you. 10, so that the problems are 10 here. 55, suppose if I give you. Okay, 55. So helium, neon, argon, krypton, xenon. So xenon is 54, which is closest to this. So what I am going to write down is xenon, which is 54, and xenon is 1, 2, 3, 4, 5, fifth inert gas. So now it will mark the ending of fifth period, and now sixth period is going to fill up. So it is going to be 6s1, right? You're able to see now. So period is going to be 6, block is going to be S, and group number is going to be 1. How many electrons in NS? 1. Clear about this, everyone? I hope all of you are able to do all these questions, right? And this session is beneficial for you, right? And please go through, if at all you got stuck up somewhere, please go through the entire thing again, and this will be really helpful for you. Okay? Thank you and have a nice day.
Madam,
Finish.
Continue.
No, it's over. Huh? Over, finish.
Over.